Now we're going to look at an application dealing with genetics. Use the following table to solve this exercise. If each parent carries one cystic fibrosis gene, find the probability that their child will be a carrier of the disease who is not actually sick. What we have here is a chart giving us the cystic fibrosis and genetic inheritance setup. It's sometimes called a Punnett square if you're in biology. Over to the left, we have the first parent, and we have the dominant gene with a capital C and the recessive gene with a lowercase c. Our second parent has the same setup, a dominant gene, capital C, a recessive gene, lowercase c. If we look at the possibilities for their child, then we can see in this first block that perhaps each parent will pass on the dominant gene, and that child will have C in its gene pattern. Perhaps the first parent passes on the dominant gene, but the second parent passes on the recessive gene. That would C with a little c. Perhaps the first parent passes on the recessive, and the second parent passes on the dominant. That would be C, capital C. And finally, perhaps the first parent passes on the recessive and the second parent also. Now, in order to come up with cystic fibrosis, to actually have the disease, you would have to have both recessive genes. So therefore, if we're looking for the probability that the child will be a carrier, meaning it will have the recessive gene, but it will not be actually sick, we're looking at only these cases where it has the recessive gene, meaning it is a carrier, but of those cases we have 2 out of 3 cases where it will not be sick. So the answer to the question would be 2/3.